Is, well, the last section is, we talked about a way to summarize the data set, right? So make it nice and pretty, put it into a little format so we can see, make it easier than just looking at random numbers. Now we're talking about graphs. So it's a little different type of graphs than you talk about in algebra, right? We're not doing X, Y charts so much, but you can see what the graphs are going to be like. But before we talk about the actual graphs, so again, just like any other section, we're talking about a little bit more definition-wise, okay? So the first thing we're going to talk about or define is something called the midpoint. Okay, so the midpoint of a class. So the midpoint is called is defined to be the upper limit plus the lower limit divided by 2. By 2. So what we want to do is you literally just add the upper and lower limits and just divide by 2 for every single one. So you can have multiple ones, right? Because this is just a class of a class, not all the classes. So I'll give you guys a simple little example here, right? Here's our frequency distribution, right? Lower classes, upper classes. And now we want to find the midpoint of every single one. So we just add them and divide by 2. So we notice we get 1, 2, 3, 4, 5, 6 new midpoints, right? Here's the midpoint between the first class, second class, third, fourth, fifth, and sixth class. So those are the midpoints. So the exact middle of it, right? So this is the exact middle of 10 and 19, right? And so forth down the line. Okay. So hopefully not too bad, right? We add them and just divide by 2. Next thing, we have something called the class boundaries. Okay, so class boundaries are the numbers in between the upper and lower class limits. Okay, so essentially it's the number right between 19 and 20. Okay, so the easiest way I can think of when it comes to it is all we're technically going to do is every lower class limit. So all of these, no matter what frequency we're dealing with, all the lower classes, you are always going to subtract 0.5. Okay, so every number here you subtract 0.5. Okay, the upper class limits, you're going to do the opposite. You're going to add 0.5 instead. So lower classes subtract 0.5, upper classes you add 0.5. Okay, so once you do that to every single number, you should now see this, right? 10 minus 0.5 gives you that, 20 minus 0.5, 30 minus 0.5, 40 minus 0.5, 50 minus 0.5, and 60 minus 0.5, right? These are the results itself. And the opposite, 19 plus 0.5, 29 plus 0.5, 39 plus 0.5, and so forth down the line, right? That's how you create class boundaries. So now notice these overlap, unlike it was before. So a frequency distribution has no overlap. Class boundaries do have overlap because of that. Okay. Now these don't change, correct? These do not change. Notice the frequencies do not change. All this is changing is the lower and upper classes. Okay, when it comes to it. So that's how we find class boundaries. So midpoints, we add them and divide by 2. Boundaries, subtract 0.5 to lower, add 0.5 to upper. Okay, itself. So why don't you guys try one? So try question 5 here. So given the frequency distribution, find the midpoints and class boundaries. So just what we did above. So just do a quick pause and just go ahead and do it. So 3, 2, 1, pause. All right, so hopefully you guys tried it out. So now let's do this together. Okay. So first, we'll just do midpoints. Okay. So remember, the midpoints is we add upper and lower and divide by 2. So 142 plus 177 and then divide by 2. You should got 159.5. Okay. And it's repeating the same thing over and over again. So adding these two and divided by 2, hopefully got 195.5. And we keep going. 231.5, 267.5, and then finally 303.5 itself. Okay. So those are the midpoints. Now the boundaries, okay, meaning, right, all of these numbers you should subtract 0.5, and these ones you should be adding 0.5, right? So you should get 141.5, 177.5, 213.5, 249.5, and then finally 285.5 for the lower. And then now you do the opposite for the upper ones, right? So you add this time. So adding 0.5 is 177.5, 213.5, 249.5, 285.5, and then finally 321.5. There's your class boundaries and midpoints. Okay. Right. So now that we know how to do both, right? Find midpoints and class boundaries. Why do we use this? That's the most important thing to deal with, right? Why do we care about these kind of things? And that is actually how do we create histograms. Okay? So how are we going to create histograms is first, so we'll just go by definition. So it's a graph consisting of bars with equal width drawn adjacent to each other, and the key thing is without gaps. So one of the key difference between a histogram and a bar graph, because I'm sure a lot of you guys have probably seen bar graphs, is one, I just said, without gaps, right? A bar graph does have gaps between the bars or the rectangles. These do not. Notice no gaps, right? Next thing is the horizontal scale, meaning the numbers of going this way horizontally, are the lower class limits. Okay, so the lower class limits, right? And the vertical scale represents the frequency of the cells. So here's a quick little example of how they would work, right? So in other words, these numbers at the bottom represent the lower class limits. And then these numbers on here are the frequencies themselves. Right? And notice it has a nice scaling. So this one's went by 2. You can go by ones, but you don't want to make it too small or too big, right? So for example, if you want to go back to our previous example here, right? If you want to we're going to do a histogram here. I wouldn't go up to like 50 because everything be shrunk together. Want to make it relatively nice to look at when it comes to it. Okay. Right. So let's try one out so you can see how this will work out. So number 6 says, now create a histogram for the 2 data sets we did earlier. So we already did this, right? Frequency distribution. So let's just quickly go back to our frequencies we did last section. Hopefully you guys have just your workbooks and you just pop those out. I'll pop them out here for myself as well. So the first one is the units one, okay? Now we want to create a histogram based off that. So I'll just quickly draw it over here. Okay, so let's make a histogram. So these numbers should be the what? Lower class boundaries, right? So it should be 4, 6, 8, 10, and 12. Now frequencies, so like I said, right, you don't have to go make them too big or too short. So notice the highest frequency is 9, so I'll just go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, the very top. Okay. All right, so now 4 has a frequency of 4, so I'm going to make a rectangle up to 4. Okay, and now 6 has a frequency of 6, so again, no gaps, right? So it should be nice and squished together. And then 8 has 4 back, so I'm going back down to 4. Okay, 10 has 2, so I'm going back down to 2. And then 12 has 9, the highest one, so all the way up to there. And there you go. There is your histogram. Pretty easy, right? Not too bad. Okay. And you can make a little slivers to define which goes where, and you can make these pretty. A lot of people just, either shade them in, but, whatever you guys want to be creative, it really doesn't matter when it comes to it. So why don't you guys try B? So again, we did this histogram our frequency already. So using the freshman portion, go ahead and quickly just do a histogram. So 3, 2, 1, pause. All right, so hope you guys did it. So let me just draw it here. So lower class limits, so 17, 19, 21, and then 23. So the highest one goes to 18, so I'm going to go by 2. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10 to 20. Okay. All right, so 17 was 8. 19 was the largest, 18. 21 was 4. And then 23 was 3. And there we go. Hopefully you guys got the same thing. All right, so those are your frequency histograms, histograms. So our first type of graphs. Okay. Now, next definition is called a relative frequency histogram. Basically, it's the same exact thing. The only difference is these numbers represent the relative frequency. That's it. So instead of regular frequency, it's the relative, so the decimal portion. But that's pretty much it. It's nothing really new about that concept. Okay. So now we're going to talk about the next type of graph we care about, and this one is the frequency polygon. Okay. So a frequency polygon is a graph that displays the data by using lines that connected with points plotted from the frequency at a midpoints of the classes out here. Here's the key thing. So frequency polygons use midpoints. Histograms use lower class limits. Okay, it's one or the other. All right. So don't be worried when it comes to it. You have to know the definition of each case. So frequency polygons using midpoints for your horizontal scale. Okay. All right. So end of this video. We'll do the examples on the next one.